we're working with rational inequalities, and the expectation is that you're not going to necessarily be able to graph something like this. There's very, very, very detailed. We'd have to spend another couple of days on graphing for you to try to get the idea of how this works. Calculus, it becomes very easy because you've got more tools to be able to graph something that kind of comes up, and this actually crosses, by the way, the HA, and then turns around and comes back down. In calculus, you know that's going to be the case because it enables you to find essentially the maxes and mins, the humps and the valleys. If you know there's a hump and this thing's going up, you know it's going to have to come back down, and you can easily find out that it's going to cross the HA. Using the picture, we could say, if we're going to graph this per se, it says what I'm really looking for is I'm looking for y that's positive or equal to 0. The or equal to 0 means that the x-intercepts are solid dots. And if I take a look at the domain is all real numbers except x can't be 0, which means my VA is going to be x equals 0. If I look at the zeros, remember the zeros really are the x-intercepts. I have that 2x minus 1 equals 0, or x equals 1/2. This is multiplicity 1. The shape that I'm looking at, this is a line as the graph crosses the end behavior asymptote. Well, the end behavior model is 2x over x squared, which is 2 over x. So as x goes to infinity, then this thing goes really theoretically to 2 over infinity. Most math people hate that notation, but 2 over infinity for all intents and purposes is 0. So this is y equals 0. So if I were to put that on my graph paper, I have an HA at y equals 0. I have a VA at x equals 0. And it crosses the x-axis at 1/2, and there's your x-intercept. Now I want to know where y is positive or 0. And if you look at how things break out, it breaks out, I have x equals 0 is the VA, x equal 1/2 is the intercept. So it's taken my paper and broken it up into 3 pieces. And what you would notice is here y is negative, then I have the VA, and the VA is multiplicity 2, so y stayed negative. Multiplicity 2 on the VA, y stayed negative, then the graph crossed the x-axis at the x-intercept, then y went to positive. So the answer would be, because it includes the x-intercept, 1/2 to infinity. So that would be the answer from the graph, is 1/2 to infinity. Now, let's say we don't take a look at the graph, and we're going to do this algebraically. Well, what would I do? first thing I do is I would solve the equal equation. That gives me the x-intercepts. And since I want, this says y positive or equal to 0, that says that at the x-intercepts I'm going to have a solid dot. The x-intercepts is where the numerator is 0. This is multiplicity 1, so the graph crosses or changes. So y will change or cross. Then I go after the domain. That's the not equal. So this is the domain. Exclusion. That has to be included. And that's the not equal, and that's where x squared, the denominator, can't be 0. So the numerator gives me the x-intercepts, the denominator gives me the VAs, the domain exclusions. So this is going to be an open dot, x equals 0, multiplicity 2, so there's no change in y. It's not a touch because it's an exclusion, and because it's a domain exclusion, this guy is an open dot. Then we go to the number line. On the number line, I put the x-intercept, which is a solid dot because it includes. And there's a change, or the graph crosses. And at 0, there's an open dot because that's the VA. Now, when I was a student in calculus, I forgot about the dang VA every single time. Well, for a while. Then the instructor would make me a note because he said, you forgot about the VA again, and that skewed all my answers. This way, if I do the equal, which is the x-intercepts, if I do the not equal, which is the VA or domain exclusions, I don't forget anybody. They're there. Now I pull a test point, and my second favorite is available to me, which is x equal 1. That's going to be my test. So if x equals 1, I want to know is the graph positive or negative. So I'm going to have 2 times 1 minus 1 over 1 squared, which is 2 minus 1, which is 1, over 1 squared, which is 1. It's positive. So positive, change, negative, no change, negative. And what am I looking for? I'm looking for positive, so that's what my answer is. So from there, I get that my answer is 1/2 comma infinity, and it certainly matches my graph. That's what we got when we did the graph. This method works for any inequality if you can solve the equality equation. And with today's technology, depending upon what you're using, of course, you can solve just about any equality equation. If you can't do it numerically, you can do it with technology. Oops.